So I'm going to point out something. So we're given the mass of a package, an object. So we're given the mass of an object, and we're given a velocity. And we're asked its kinetic energy. And notice it says it's moving. So it's proper that we should be trying to find its kinetic energy, because kinetic is all about motion. If it's being still, there's no kinetic energy. Only when it's moving is there kinetic energy. So the kinetic energy formula is 1/2 mass times velocity squared. So what you need to be told is the mass and the velocity, and that's what we were told. And then your answer is in joules. Well, the unit, we've seen joules before. The unit for work, we were told, is joules. So kinetic energy is a type of work. Now let's look at this one. We have a weight of a package, we have a force, and we have a distance. And then we're given friction that opposes it, that opposes this. So that's why you subtract it. But anyway, that gives you your force, and then times your distance. Work is force times distance, and your answer's in joules. So look, kinetic energy is in joules, work is in joules, but it's two different formulas. But you can sometimes use them together in a problem. And then let's go down here. So we have, they ask what is the gravitational potential energy. They give us a mass of an object, and they give us the height above the ground that it is, and that's all they give us. But that's all we need, because potential energy is mgh, mass times gravity times height. Gravity, we know what that is. That's always 9.80 or something close to that meters per second squared. So for a potential energy problem, all we need is mass and height, and they give us the mass and the height. So for kinetic energy, we need mass and velocity. So mass and velocity. For potential energy, we need mass and height. Mass and height. And then for work, we need mass and then force and distance. Actually, we didn't even use mass for this one. So that was an extra thing. We just need force and distance. So kinetic energy is mass and velocity, potential energy is mass and height, and then work is force and distance. And they all have units of joules, because kinetic and potential energy are different forms of work. So I just wanted to point that out. Here's another one that's kinetic energy. So I bet they gave us a mass and a velocity. Let's see. We've got the mass of an elephant, and we've got the mass of a sprinter, and we're given a velocity. So for this problem, it says how fast. How fast tells me we're looking for velocity. So we're given the mass of the elephant, but not his velocity. We're given the mass of a sprinter and his velocity. So we use our mass and velocity to find the kinetic energy of the sprinter, and then we're saying, in order for the elephant to have that same kinetic energy, what must the velocity be? So this time you're given the kinetic energy of the elephant that you are pretending it is, and you're given the mass, and then you have to find the velocity. So the reason the equation looks this way is because they algebraically manipulated it. So we may need to work a bit on that, but just the idea of mass and velocity is all you need for kinetic energy. This one's a little bit more complicated, but just as an overview, I wanted to point that stuff out.